Hello, everybody. I am alive, believe it or not, but just barely. Sorry I couldn't be there. I'm very sick, and hopefully I'll be back to school soon. Um, but anyway, I apologize now. I'm not gonna be able to give you headphone warnings about when I'm coughing or sneezing. Just bear with me, okay? Or just turn off the volume and write down the stuff that I write down, because I'm not gonna say anything too crazy. Mostly because I just want to get it done. But let's go ahead and get started. So today, again, I sound horrible, and I apologize. We're going to do systems of equations. It's very similar to systems of inequalities. It's just two steps less than systems of inequalities because you don't have to shade. You don't have to worry about solid versus dotted. Okay? So let's go ahead and start with vocab. A system of linear equations, coughing, is a group of two or more linear equations with the same solution. Okay? So it's basically we're going to graph a bunch of lines on the same graph, and we're looking for what ordered pair they all have in common. Okay? Now, a solution to the inequality is the ordered pair, so that's what we look for a solution, is the ordered pair. That makes all the equations in the system true. Okay? Now, if we're going to do this algebraically, we're just plugging in the x and y from that ordered pair and testing it in each equation to make sure it comes out true. We get an equal statement. On a graph, though, when we graph it, which is what we're totally focusing on today, it's just graphing, it's the ordered pair that all the equations share. So it's where all the lines intersect or overlap. Okay? So there are four kinds of systems, okay? Consistent systems, which is a system of equations that have at least one solution, at least one, okay? And from there's two kinds. Independent consistent systems, which they have exactly one solution, and dependent consistent systems, which has infinitely many solutions. Okay, and I'll show you what these look like in a second. And the last one is inconsistent systems. This is hard to say when you're all congested. Which is a system of equations that has no solution. Okay, you will need to know this terminology. Okay, so consistent independent. This is an example with two lines. So this is a system of equations. They're intersecting at only one point. So that one ordered pair is the solution. Okay? Consistent dependent would be like they're the exact same line, which means that all of the ordered pairs on that line work for both equations. So they're all solutions. So this is infinitely many solutions. And then finally, inconsistent is when there's no intersection, so they're parallel, which means there's no solution because they don't have any ordered pairs in common. Okay? Three ways you can solve systems of equations. One is graphing, which is what we're going to do today. The next one is substitution, which we'll do next class. And the last one is elimination. Okay? And we'll do that the next class, whatever order we're doing it. So solving systems by graphing, four steps. 4 steps? Yeah, 4 steps. 1, change all equations to slope-intercept form. Graph the equations on the same graph. It might be helpful to use different colors. Find any points that the equations have in common, so the intersections or the overlap. Those ordered pairs are your solutions to the system. And the fourth one is check your solution, plug it into the equation to see if it comes out with a true statement. Coughing. Okay? So, slope-intercept, graph, intersection or overlap, check. Those are your 4 steps. So example 1, find the solution to the following system. Here's the system. So, and normally there's that little brace around everything. So this one I got to get y by itself. So I subtract 3x from both sides. I'm here. Divide everything by -1, gives me y equals positive 3x minus 6. I can graph that line, which means way down here. See if it'll show up for me. Where's the other half? Where's the other half of the line? Dude, don't mess with me. Don't they know I'm sick, guys? Ugh. Oh, gosh. What is happening? I can see it. I see it right there. Why is it not clicking? Weird. Weird. I don't like it. Oh, that showed up. Ah! Okay. You gotta love the technical difficulties that show up with it. Oh, God, that's so annoying that it does that. Alright, let's do this, and I'll just graph it again. So it goes through. Come here. What now? Really? What is up with this red line? Oh. Odd childs. Alright, so I'm going to try to do this again. So here's -6. It is going that way. And then goes that way. That's an estimation. Sorry, guys. Use your slope. 3/1. Just trying to draw what's already there. I already graphed the y equals -2x plus 4. That was in the black. You can see it crosses. They cross each other right here at 2, 0. So that is your solution right there. Now to check it, to make sure we're right and we didn't graph something wrong, we just go ahead and plug it in. So I plug it into the first one. So 3, I plug it into the original one they gave me. 3 times 2 minus 0 gives me 6 minus 0. 6 equals 6. That's true. Plug it into the second one. 0 equals -2 times 2 plus 4. -4 plus 4 equals 0. 0 equals 0. That's true. So because it worked for both equations, it is a solution. Okay? Try this one on your own. But we're getting it into slope-intercept form first, then graph it, find the intersection, and then go ahead and check it. Okay? Example 2, write the system for this and the solution for the graph. Well, we're just writing the equations then. So this blue guy is hitting at -4, and it looks like it's going up 2 and over 3. So y equals 2/3 x minus 4. This guy is going through 1, 2, 3, 4, 5. It is going down 1 and over 3. So that's got a -1/3 slope, plus 5. The solution is where they're crossing. So right here, which is 9, 2. That's it. Okay? Try this one on your own. Create the system and find the solution for it. Okay? Sorry, I'm going really fast. To be very honest, I want to get it done because it's starting to hurt my head. Okay? If you have questions, so write it down. If I'm going way too fast, rewind and pause it. Okay. And then when I get back to class, I'll answer all your questions for you. Okay? Wait, was that it? Oh, that was it. I'm so good. I'm awesome. Okay, well, that's that. Hopefully you don't have any questions, because that would be amazing if you didn't. But if you do, I'll answer them next time. And yeah, that's it. Okay? I will see you guys hopefully next class. And yeah, bye.